Alright guys, so this is the last video for our lesson on angles and their measure. In this video we are going to talk about the arc length formula. And in general, when we are looking at the arc length formula, we always want the angle in our arc length formula to be in radians, right? So in general we're going to say that if theta is a central angle in radians of a circle of radius r, then the length of the inscribed arc S is given by this formula. S equals R times theta. Now, when we're talking about that arc length S, remember that we're talking about the portion of the circle that is covered by the central angle. So if we've got our initial side and then some rotation to a terminal side, right here, that would be this rotation right here. We would say that S is the arc length, that is the portion of the circumference that our angle, and another way of saying the angle covers that portion of the circumference is that we say that the length is inscribed in the angle. So right here, this formula should make some sense to us because, of course, when we're talking about an angle in radians, we're basically saying the angle is telling us how many lengths of the radius our rotation is covering for a central angle, right? So really what we're saying is that the arc length is going to equal the radius times the number of radiuses that we have along the perimeter of the circle, right? So right here, given a central angle of 1.23 radians and a radius of 5 inches, find the arc length. Well, this obviously is just plugging in. Right here we would say that we have our radius of 5 times our angle 1.23 radians, and that is going to give us an arc length of 6.15. So right here, drawing this out, here's the initial side of our angle. We're saying that we are rotating a little bit more than 1 radian, so that's a little bit more than 1 length of the radius we're going to cover with our rotation. And right here, we're saying that this is the length S that we have, which is our 6.15 inches. Right here, we've got the radius as that 5 inches. And again, this should make some sense to us because what we're being told is that our rotation is 1.23 radians, which means that our rotation is covering 1.23 radiuses along the perimeter of the circle. So right here it would make sense that we have a little bit more than a length of the radius as our arc length, right? We have essentially 0.23 more than the radius as our arc length. When we're looking at arc length for degrees, what we have here is a formula that actually combines the conversion formula from degrees to radians with the arc length formula. Really right here what we have is r theta times pi over 180, right? So this equation that the book gives us is actually just combining the multiplication of pi over 180, which would convert our angle measure from degrees to radians, right, with the equation for arc length itself. So right here, why don't you guys go ahead and pause the video right here. What I want you to do is to convert our angle measure, that 54.7 degrees, into radians, and then go ahead and use the original arc length formula. S, the arc length, equals the radius times the angle measure, where this angle measure right here is in radians. So pause the video right here and give this one a shot. So right here, we're looking to convert our angle from degrees to radians, so we multiply it by our pi over 180. I just typed this whole piece into the calculator and came up with approximately 0.9547 radians. Now right here with that as our angle, in radians we can say that we're going to be traveling a little bit less than the length of the radius along the perimeter of the circle with our rotation. And so right here, when we plug into our formula for arc length, where our angle is in radians, we'd say we've got a radius of 5 times our 0.9547 radians, giving us an arc length of 4.7735 inches. And right here, that should make sense again because our rotation of radians is telling us that we have a little bit less than a length of the radius that we've traveled along the perimeter of the circle. So right here, why don't we go ahead and give this next one a shot. A car wheel has a 5-inch radius. What is the rotation, the angle, the wheel turns when the car rolls forward 4 feet? So in general, we would like all of our units of length to be the same. So right here, 4 feet we can convert to 48 inches. So now our rolling 4 feet and our radius of 15 inches are the same. So if we're thinking about a car tire rolling across the ground, really we can see that as the tire rolls across the ground, we're seeing the distance that the tire covers as really the amount of the tire's perimeter that has made contact with the ground, right? So right here, the arc length is equal to the distance traveled, right? So that's how we want to think about that 48 inches when we're coming up with the amount of rotation that the tire has done to cover that 4 feet or that 48 inches. So why don't you guys go ahead and give this one a shot, and we'll come back and look at it together in a second. So right here, as we think about that distance along the ground that the tire has rolled as being our 48 inches, and that's equal to the amount of the perimeter of the tire that has made contact with the ground, or the arc length that the tire has turned along the ground, we can basically see that right here, this is maybe a little bit generous, but the portion, you can see here that the amount of rotation the tire has done is basically the amount of turning that would allow the tire to make contact with the ground. So right here, our arc length is 48 inches. We know that our radius, R, is 15 inches. And so right here, we plug all this into our arc length formula and solve for the rotation. So right here, dividing both sides by 15, we would say that the car tire has rolled 3.8 radians, which is approximately 183.35 degrees. All right, guys, so that's the end of this video, and we will look at this stuff tomorrow in class. All right.